So these first few, this first section here, you're doing a derivative of an integral. So for the first one, both of the boundaries are just values. It's 0 to 7. When you do the derivative of just a value, you're going to get 0. So that just ends up being nothing. All right, for this one, all you have to do is take x and plug it in for t. Remember, I said like the only way you're going to miss these is if you try to do anything. The derivative and the integral cancel each other out. Like they undo each other. So you're not doing an integral, you're not doing a derivative. All I have to do is plug x in. So this would be tangent cubed of 4x. And then this one, now we switched the boundaries. The variable is now on the lower boundary. So that means that we're going to need a negative. They've been reversed. So we have a negative. And this one's also going to involve a chain rule. There's a 2x cubed there, and you have to multiply on the chain, the derivative of that 2x cubed. So I'm just going to go ahead and put that out front. Derivative of 2x cubed would be 6x squared. And then you just have to plug the 2x cubed in for t. So we're just going to plug that 2x cubed in for t, and then that'll be our answer. So 1 plus square root of 2x cubed squared, and then that whole thing is to the 5th. And that's it. I'm not going to make you simplify them down. You can if you want to, but you don't have to. The whole test is, free response. So we put a negative because the boundaries were reversed. We did a chain rule for this part because it was more than just x. And then I just took that 2x cubed and plugged it in for t. All right, number 4. We're given this function that's an antiderivative. This is in terms of an integral. This is accumulation here. F of 7 equals 4, find f of 9. This is like a lot of the ones in the homework that we just did. This f of 7 equals 4 is an initial condition. We're starting at 4. This is going to be 4 plus accumulation. And let me throw this question at you guys. What are going to be the boundaries on the integral? Hint, they're given in the problem, but you just got to look. It's going to be from where to where? And I'm going to wait until I get a few answers because I need to know that you guys are there with me. I can't see you, and I know sometimes it's hard to listen and type at the same time. I don't mind waiting. I need to know everybody's with me. Okay, good. 7 to 9, perfect. It doesn't start at 0. It starts at 7, and we're trying to get to 9. So 7 to 9, and then sine of 3t squared dt. And that is what we are going to put in our calculator. So again, I can't see you, so I don't know what you're doing. Like, I hope that most of you are following along and writing it down and doing this in your calculator, but I can't see you, and I don't know, like, I hope that you are. Please don't just watch me do this and then try to figure it out when you're taking the test. Okay, the button pushing is a skill you got to practice, right? 4 plus integral, and then 7 to 9, and then we're going to put sine of 3x squared dx. And that will literally give you your answer. Make sure you do 3 decimal points. You can truncate or round. I like to truncate because I just think it's easier. To the first 3 decimal points that you see. Oh, this one is having to think for a minute. There we go. All right, so 3.989. And again, you can just take those first 3 decimal points, 3.989. All right, I'm going to skip this next section so that leaves some for you to try. You're going to need to break this up and find the areas of all of these shapes in here and then use them to answer these questions. And then this increasing, decreasing, concavity and all that stuff, that comes back to this. So, use your sticky note and you will be able to answer all of this. Again, I'm going to post all the answers. And if you want to go over them in office hours, come see me. But I'm going to leave those for you guys to try. So number 9, this is a rate in, rate out problem. We're shoveling snow off the driveway and it's snowing. So snow is coming in and we're shoveling it off, snow is going out. All right, a rate in, rate out problem. So snow lands on the driveway at a rate in cubic feet per hour of, all right, this is the rate in, if you want to label it. All right, so that's rate in. And then we're shoveling snow off the driveway at a rate of, and this is 3, because you're a machine and you don't get tired. That's a constant rate. Word problems are funny. All right, that's the rate out. Rate in, rate out. Initial condition, the driveway was clean at 0 hours, all right? So we initially started with nothing. You were like getting ahead of this snowstorm, right? So letter A, what is the net rate at which snow is landing on the driveway at time 4 hours? These equations are rates, and you were asked for a net rate. So you don't have to do a derivative. You don't have to do an integral. All you're going to have to do is plug in 4. Rate in minus rate out. So this is going to be 30 e to the power -1/2 times 4 plus 1. That's the rate in. So I just plugged in 4. And then minus the rate out, which is 3. So rate in minus rate out at time 4. And again, we're just going to type that in. All right, so 30 e. Now it's to the power -1/2 times 4. That would be -2. And then plus 1 minus 3. Or you could just type -2. I'm just trying to show that they are from 2 separate equations. The plus 1 was part of this equation, and then minusing the rate out is the -3. Right, again, 3 decimal points. So 2.060. And then we have to put units, guys. This is a rate that we found. So what are going to be the units since it is a rate? Good, we're going to have a per in there. It's going to be something per hour. Good, we just need to cube the feet. The reason it's cubed is because it's a volume of snow. So it's feet cubed per hour. But good, we need a per in there because it is a rate, something per something else. So cubic feet per hour. All right, letter B. How much snow is on the driveway at time 4? Now, this is an accumulation. All right, so now we're going to need to accumulate snow. It's what you started with, which is 0. I'm just writing the 0 so you can see that would be the initial condition. All right, if there was one, you'd have to put that. All right, so 0 plus, and then it is integral from 0 to 4. And we want rate in, which is S of t, minus rate out, which is H of t. So it's the initial condition, which is nothing, plus, and then we want to accumulate snow from 0 to 4 hours, rate in minus rate out. All right, now I'm not going to type the 0 plus because that's just nothing. But integral from 0 to 4, and then S of t is this equation right here. So 30 e to the -1/2 x plus 1. So that's rate in 30 e to the -1/2 x plus 1, and then minus 3. Again, you could just put -2. I like to keep them separate though, so you realize it's rate in minus rate out. If you start to like mesh them together, I feel like it confuses what's actually happening. So that's why I wrote it separate. So rate in minus rate out, dx, enter, and then this is your answer. Again, 3 decimal points. So it's going to be 43.879. All right, now units for this. Units are huge on this test. These are like mostly word problems. You're going to have to put the units or you're going to lose points. This is just an amount of snow. How much snow? So it's not a rate, it's just how much snow. So what are going to be the units for that? What would be the unit for just an amount of snow? Close. It will be just feet. There won't be like a per in there, but it'll be good. It'll be cubic feet. Again, the reason this is cubed is because it's volume. So feet cubed, cubic, or you could write out in words cubic feet, which is a little bit longer. But again, the reason it's cubed is because it's a volume of snow. All right, letter C. Set up the integral equation that would give the time x at which all the snow is gone. So this is like, remember the party problem and all the people were gone, or the M&M problem and the bowl was empty? It's just like that. So what we started with, which is nothing, plus the accumulation from 0 to x, and it's going to look just the same as this one, rate in minus rate out dt, and you're going to set that equal to 0. Again, because it's when there's no snow. So it equals nothing. And then letter D, is it possible to solve that equation? So it's really a yes or no. I just want you to like write a sentence to justify it. The question is, are you going to be able to shovel all the snow, or is it going to snow so fast that you cannot keep up, right? Listen carefully. You need in your justification to do a comparison between the rates. So your answer needs to say greater than or less than in some capacity. You need to say a greater than or a less than, because we need to use those comparison words. And here's how I would suggest going through this, is go to y equals, and I'm going to type in the rate in and the rate out in y1 and y2, and we'll just look at them, right? So rate in, 30e to the power negative half x plus 1. That was the rate in. Rate out is just 3. It was just constant. Because again, you're a machine and you don't get tired. You can just shovel at a constant rate and never get worn out. All right, so it was rate in, rate out. I'm just going to do zoom 6 for standard. So here it goes. All right, so this is the rate at which it's snowing. So it starts snowing really, really fast, and then it's still snowing, but the snowing rate kind of slows down. Like it's decreasing rate. So it's snowing a whole lot, and then it's still snowing, but not quite so much. And then you're a machine. Again, you shovel at a constant rate. So you're eventually going to catch up. Do you see how the two graphs intersect? And your shoveling rate is going to be above the snowing rate. So you're eventually going to overtake the snow. Your shoveling rate is going to be greater than the snowing rate at some point. Right? That's how you would say this. Can we solve the equation? Yes, we're going to be able to shovel all the snow off. S of t, or you could say, you know, the rate of snowing will be less than, and you need to say a greater than or less. I don't care how you word it. You can put it in your own words, but you need to do a comparison. S of t will be less than h of t, you know, at some point. Now, let me just, by way of doing another example, let's say that these didn't intersect. Like, let me move this up. Let me make that 1 of 5. I'm altering the problem now. So this is like going into theoretical territory here. Say it looked like this. Then would you be able to shovel all the snow? Like, would you eventually be able to catch up? No. And so your justification would need to say something like, the snowing rate will always be greater than the shoveling rate. We will never catch up. Again, use a comparison word like less than or greater than. Like this rate is always going to be greater than this rate. Okay, so you just need to be able to compare them. All right, number 10, you're going to need a separate piece of paper. All right, there's no way that your answers are going to fit on here. All right. So we'll go through number 10 and then I'll give us another break because again, I know these problems are a lot. Right, so g of x is an accumulation function. The accumulation begins at 6. That's right here. F is the graph shown to the right. Now, I'm not going to take off points for this on your test, but on the AP exam, you have to link these together. And I've written it with each problem that we did, but you have to put this on the AP exam. G prime is f of x. When you do the derivative of this, you just take x and plug it in. You have to link these together. Again, I won't take off for it, but on the AP exam, if you don't write this at some point, they won't give you credit. You have to link those together. G prime is the derivative of this. This is going to be all this good stuff. All right, so all these justifications. Now, we're going to need to find all of the areas over here. So I'm going to just go ahead and do it now because we only have a few shapes here. This won't take long. So let me just go ahead and find all these areas right off the bat, and then we won't have to stop what we're doing and come back and find them later. All right, so this first triangle is 1/2 base times height. The base is 3, the height is 4. So that is 6, but it is negative since it's below the x-axis. All right, and then the semicircle, 1/2 pi r squared. The radius is 3. So that is 9/2 pi. And then this triangle is the same size as this triangle. It'll just be a positive 6 since it's above sea level, it's above the x-axis. All right, so letter A, state the critical points. I didn't ask you to justify everything. I didn't say put a justification for this one. So if it doesn't say to put one, don't put it. Again, this test is going to take you the full block, and you don't want to take time doing stuff that you don't need to do. Critical points are where the derivative equals 0. So where does this graph equal 0, guys? Hint, there's 2 of them. What are our critical points? Yeah, good. Nice job, guys. Perfect. We've got one right there, 0, and then 6. Now, if you were going to justify, you would say because G prime equals 0 there. And I went through all of that whenever I taught it to you. I went through all of that in the notes, okay? Because derivative equals 0 there. All right, B, is each interior critical point the location of a relative maximum, relative minimum, or neither? Justify your answer. So we're going to write a sentence for each of these, and it has to start G of X is or G of X has. So let's look at 0. G of X has, now at 0, the derivative changes from below to above. That is negative to positive. So what does that mean G of X has? If we go from negative to positive, G of X has a relative what? For negative to positive. And good, nice job, got minimum, perfect, all right. G of X has a relative minimum at X equals 0 because derivative changes from negative to positive there. It's a little annoying to write out the sentence, but it's not difficult. It goes in the tedious but not difficult category. I've drilled these into, done these so much, it just should be like, comes to you naturally, all right? And then at 6, what's going on? What are we gonna put for X equals 6? I'm looking for maximum, minimum, or neither. Those are your choices here. So what are we going to put for X equals 6? Maximum, minimum, or neither? Good, nice job, guys. It'll be neither. Neither a relative maximum or minimum at X equals 6 because, and it's because the derivative doesn't change sign there. The derivative, you could say stays positive. I like to say doesn't change sign because it's like it's neither because it does not do something. But however you want to word that, because G prime does not change sign there. Positive to negative gives you a maximum. Negative to positive gives you a minimum. If it doesn't change sign, then you get neither. All right, C, state the intervals where G is increasing and decreasing. I did not ask you to justify this one, so don't. Again, I don't want you to take time doing something that I didn't ask you to do, right? So G of X is increasing. Let me pull out my sticky note. All right, increasing is where the derivative is positive. That means above sea level, right? So this graph is positive from 0 to 9. Sorry, I have to keep moving this up and down to make everything fit. Increasing 0 to 9. Now, if you were going to justify, it would be because G prime is positive there, because G prime is positive there. And then G of X is decreasing wherever the derivative is negative. That means below sea level. So this graph is below the x-axis from -3 to 0. I'm gonna have to fold this paper over here, so I stop moving this around. I don't wanna make you seasick. All right, and if you were gonna justify that, it would be because G prime is negative there. I'm bringing it up verbally just to be thorough, but again, don't write it if I didn't ask you to. I know that sounds like I'm telling you to be lazy, but I really just want you to be efficient because these problems take a lot of time and you only get one block. All right, letter D is asking for absolute extrema. All right, so what test do we do for absolute extrema? What is that test called? Good, candidates test, perfect, all right. And then who are the candidates? What are the candidates that go on the chart? And you don't need to give a specific number like a numeral, just in general, who are the candidates that go in the chart? Good, endpoints, good. And zeros is fine, they're critical points, endpoints and critical points, which are the zeros of this graph. All right, so nice job. All right, endpoints will be -3 and 9. And the critical points are 0 and 6. All right, so we're going to test all of those. And our accumulation starts at 6. Be careful with that. It might not be 0. Sometimes it is, but in this case, it's not. All right. So we're going to plug in -3. So that's going to be the accumulation from 6 to -3. Now we're going backwards, so everything is going to be opposite. So it'll be -9/2 pi plus 6. All right, and then 0. So from 6 to 0, again, going backwards, it'll be -9/2 pi. From 6 to 6, you didn't go anywhere, so that's 0. No accumulation. And then from 6 to 9 is 6. Now let me just like see what these would be roughly, just to compare these here, because we have to see which one's the biggest and the smallest. If you treat pi roughly as 3, it's 3.1415, treat it like 3, just to see like about what this is going to come out to. So you'd have what, 9 times 3 would be 27. Gosh, divided by 2, what is that? 13.5. So -13.5 plus 6 be -7.5. Did I do that right in my head? Are you guys double checking me? It's Monday morning and I'm struggling mentally to add and subtract. -7.5. You did -9/2 times 3 and then plus 6. Yeah, -7.5. I was triple checking it in the calculator there. Right, and then so if you do -9/2 times 3, that would be -13.5 roughly. Okay, again, I'm just estimating because we have to write out which one's the biggest and the smallest. All right, so the absolute maximum is, the biggest result we got is 6 at x equals 9. And then the absolute minimum is, now this is the smallest one we got, -9/2 pi at x equals 0. So this is your answer, and it says to justify, but you don't have to write anything else. The chart acts as your justification. So that is your justification. You don't have to say anything else there. All right, so letter E, find the inflection points. I'm gonna have to bend this paper over again so that you guys can see it here. Let me pull out the stick-it note again. Inflection points means a change in concavity. So that's where our derivative graph, that's this one, changes from increasing to decreasing or decreasing to increasing. This is the annoying one to justify, but I didn't ask you to justify it. So you don't have to write out that really long sentence. All right, all we have to do is find them. So where does this graph change from increasing to decreasing or decreasing to increasing? Well, let's see. We are increasing all the way until right here, which is 3. And then we decrease, and then we change back to increasing again at 6. So 6 is kind of an interesting point here. This is both a critical point and an inflection point. So it was both, which is interesting. All right, and then letter F. State the intervals where G is concave up and concave down. Again, I didn't ask you to justify, so you don't have to write it. Concave up is where this graph is increasing. Concave down is where this graph is decreasing. All right, so G of X is concave up from -3 to +3. And then we're also increasing from 6 to 9. And the justification would be, I'm just bringing it up to be thorough, because G prime is increasing there. And then G of X is concave down wherever this graph is decreasing. So that's going to be from 3 to 6. And again, the justification would be because G prime is decreasing there. I'm going to need to make a new stick-it note because I've pulled it off my wall so many times it's like not sticky anymore. All right, and then this last thing is just putting it all together. So I'm going to start by plotting the points that I found on this chart here. So I'm going to start by plotting these. So -3, -7.5. Good enough. And then we had 0, -13.5. So right there, we have 6, 0, and 9, 6. So those are the end points and the critical points. We just need to go back and also do the inflection points. Now, the only inflection points that we had were 3 and 6. And we already did 6 because, like I said, 6 was both an inflection point and a critical point. So I really just need to add onto this chart 3. I'm just going to add 3 onto there. So we need to take 3 and plug it in. Now, remember, your accumulation started at 6. So we want to go from 6 back to 3. So this is going to be treated as negative, and it would be half of this. So instead of 9/2 pi, it would be 9/4 pi. We're breaking this in half, like we're doing this area. All right, so that would be -9/4 pi. And again, if you treat pi like 3, well, it would be half of this. So half of -13.5 would be -6.75 roughly. Again, it's like close enough. I just want to get a point on the graph that's like roughly close enough. So like almost -7. So we got 3 and then like not quite -7. All right, so there's all our important points. We have the end points, we have the critical points, we have the inflection points. And you just want to connect it with the correct concavity. So again, this is so annoying because I can't show all of this at the same time. Here's our concavity. We want to be concave up from -3 to 3. So that's from here to here, -3 to +3. We want to be concave up, so like a smiley face. And then from 3 to 6 was concave down. So you need to switch it so it bends the other way. And then from 6 to 9 was concave up again. So it was concave up, concave down, concave up.